Hello and welcome back. In this video, may we apply the concept we've learned, extrapolation and linearization and other methods in the scientific method lessons. Can you take all of those concepts and then apply them to answer some few questions from past papers? So I've selected questions particularly on the scientific method. So in this video, we will do the scientific method questions from past papers. And we will apply, and you will see that all the concepts we've covered in the previous videos are sufficient to answer these questions. So let's dive in. This one is a question paper from I think it's November 2014. Question 8. So 8.1, a group of learners conduct an experiment to determine the EMF and internal resistance of a battery. They connected the battery to a rheostat, which is a variable resistor, a low resistance ammeter and a high resistance voltmeter as shown in the diagram. So then these are the readings on the voltmeter. When the voltmeter reads 2 volts, the ammeter reads 0.58 amperes. And when the voltmeter reads 3 volts, the ammeter reads 0.46 amperes, and so on. 8.1.1, state one factor which must be kept constant during the experiment. 8.1.2, use the information in the table to plot the points and draw the line of best fit on the attached graph sheet. And then you can use the graph that you have drawn to determine the EMF of the battery. And that is 8.1.3 and 8.1.4. The internal resistance of a battery without using any form of the equation. E is equal to I into big R plus small r. Okay. If you look at the last video on extrapolation, then this question should be trivial, should be very easy to answer. So let's start with question 8.1.1. Just get my pen there. 8.1.1. The obvious, we must make sure that we keep the temperature constant. Okay, so that is important factor. And then 8.1.2, we will have to plot the points on the graph. You are provided the graph paper. So this is voltage on the y-axis and the ammeter on the x-axis. So we will plot here, and then we will draw the line of best fit. And then we can use extrapolation to determine the EMF, and then use gradient to determine the internal resistance. All right, here I've plotted the points, and I'm just going to read you the scale. So this scale, as you can see, from 0 to 0.2, and then that's on the x-axis, 0.2, 0.4, and on the y-axis it's 0, 2, 4, 6. So then when we move on the x-axis, we will move by 0.02, 0.04, 0.04, 0.6, 0.8, and this would be 0.1. So 0.1 is here. Okay, and then on the y-axis, so since this is 2, then basically these grid lines, they are 0.2. So that's 0.2, 0.4, 0.6, 0.8, and then that's 1. And then 1.2, 1.4, 1.6, 1.8, and then that's 2. And then you can plot all these points here. And then after you've plotted the points, the next thing would be to take your ruler and then just join the points using the line of best fit. And the line of best fit here is a straight line, so that's what I'm gonna do next. Let me do that. So I'll just pick up a point here, and then you can draw all the way, and then you will cut the y-axis there. So that is your line of best fit. Might want to fix this line a bit, but yeah, this is my line of best fit. So what is this value here? My EMF, that is 8. So that's 8, and then that is 7, 8, 7, 6, 7, 4. So my EMF is equal to 7.4 volts. So that's my EMF there. So I'm just gonna write that down. Okay. So let's just do this. Let me write here the EMF. That's 8.1.3. So because we've done 8.1.2, 8.1.3, the EMF is equal to 7.4 volts. And then we do 8.1.4. So we've determined the EMF using extrapolation, but I've just drawn the line of best fit here, and then I extended it so that it cuts the y-axis, so which is the extrapolation part. So the internal resistance of a battery, without using this equation here, in our calculations, all right? So we won't use this equation in our calculations, but we will have to rewrite it so to make sense of it. We must use linearization to answer this question. So this is going to be the EMF is I into R plus small r. So then that implies that as we can see, our graph is the y-axis is V external. So again, you can check the previous videos on this material. So I'm not going to use this equation to calculate R. I'm just going to sort of state that this is in the form y is equal to mx plus c, with y equals v external, and m is equal to minus r, which is what I'm looking for, and c is equal to minus EMF. Sorry, this should be positive. It should be positive there. Okay, so we will determine this internal resistance when they say without using any form of this equation. We're not going to use this equation, but we must use the fact that this information is in this form, so then we will calculate the gradient using the graph. That's what they mean. So let's do that. Okay, so let me I'll just select any points here I already know. Yeah. Going to say that the gradient, because we want the internal resistance, so the gradient M is going to be delta V, changing the variable in the y-axis, divided by changing the variable in the x-axis. And we know why we're doing that. That means that our minus R is this delta V over delta I, and I'm going to select these points. This is 0.58 when it's 2, and 0.36 when it's 4. So I'm going to select those points. I'm going to say 4 minus 2 divided by 0.36 minus 0.58, right? Okay, so let me do this here, and then I'll go to looking for this guy. Here is this guy. Okay, maybe he should be up there. Okay, and then I'm just gonna insert this. I'm going to insert this calculation. That's 4 minus 2, and then I'm going to close that, and then I'm going to divide by 0.36 minus 0.58, and then we'll get this one answer there. Our answer, so minus r is equal to minus okay, maybe which one to remove? This one. Okay, all right. It's going to be minus 9.09, and I'm going to stop there, which implies maybe let's put ohms there, which implies that R is 9.09 ohms. Okay, that's our final answer. Right. I'll stop here this video, and I'm gonna upload this video so you can take a look at it, and then I'm going to continue with other questions in the next video. Thank you for listening. Goodbye.